which is this, vertical circles. And this will be the last slide for today. All right? Let's talk about an object going in a vertical circle. Everything we've done so far has been horizontal. So we've kind of been ignoring gravity. We've just been saying, okay, it's going in a circle. Either gravity's balanced out by the normal force, or just gravity is the centripetal force causing the satellite to go around the planet, whatever it is. Let's look at a vertical circle now. So we've got the Earth down here, right? You know it's the Earth because there is green grass. Okay, so I got my green grass, and now I'm taking a rock or something. So here's me. Yes, I am very skinny and awesome. So that's me, and I am holding a string, which of course has a really big rock on it, which I am spinning in a circle. Okay, so let's talk about this just for a minute. You got the idea, so I'm going to go ahead and erase my lovely picture so that I have space to talk about this. But you know what's happening now. We got the idea of what this looks like. Okay, so let's talk about here. The rock is here at the bottom. All right, so if the rock is at the bottom, what direction is the centripetal acceleration? Well, the centripetal acceleration, of course, must be up. Okay, I need a certain amount of centripetal acceleration. No matter where I am, if I want this rock to be going, if I want it to be at a constant speed, which is what I'm going to look at first, if I want it to be a constant speed, then I have to have a constant acceleration towards the middle, right? Now, in this case, what are the forces acting on my block? Well, you've got the force of gravity, which is down, okay, and that's constant. What other force is on this block? Well, really the only other force is the tension, right? But if gravity is down, how much tension do I need there? Well, it has to add with the gravity to end up giving me this centripetal acceleration. So it's got to be whatever that acceleration is, plus enough to oppose the gravity. So at this point, my tension is very large and towards the center, right? That will give me the acceleration needed to be towards the middle. Let's move our block over to the side now. Now my centripetal acceleration needs to be towards the middle, and I'm going to try to make it approximately the same size as it was before. Now, which direction is gravity and tension? Well, gravity's going this way. Okay, so we've got the force of gravity pulling this way. We've got tension pulling that way. Okay, now that means something. If it's just tension, we've got a problem. Because tension and this force of gravity will never balance out to give us this centripetal acceleration towards the middle. Okay? That's why when you're swinging a rock, you can't just leave your hand in the same place. And if you do, your fingers have to be moving. Because when you're here, you actually cannot be pulling straight horizontally when we're at this point. Okay? In order to end up with this acceleration, which is towards the center of the circle, then at this point, I need to be pulling up slightly. Okay? And so I have to have a tension pulling up slightly so that it balances the vertical component of gravity. Right? And that's the only way that I can keep this rock moving in a constant velocity. All right? Now, when I get to the top, then things again are going to change, right? Because now I've got my acceleration, which still needs to be towards the center, but I've got the force of gravity, which is pulling down like this. Okay? So if the force of gravity is equal to the acceleration at that point, wonderful. That means that there is no tension in the string. Now, this can cause a problem. If the force of gravity is larger than the centripetal acceleration needed, that means the force of gravity is going to be pulling down. The tension would actually need to push up, which it can't do. The tension is not able to push up to balance a larger force of gravity. So because of that, it's possible that if I don't have a large enough speed requiring a large enough centripetal acceleration, that my rock, rather than getting to the top, will not make it as high, because it has to be at a point where the acceleration and the gravity are matched up, because the tension cannot offer that force. This goes into that question we looked at a couple of days ago in class, where we looked at one where it was a pendulum with a solid central pole, the rod, and in that case that was able to offer a force holding the object up in place, whereas the force of gravity and acceleration were both pulling down. Okay, the acceleration, was due to the force of gravity, the balance between the force of gravity and that acceleration. Okay, so some interesting ideas. Talk through this, look through it again, make sure that you understand what's required in order for this vertical motion to be in a circle. Now, what if I want there to be a constant tension? Okay, so let's just say for a minute that I keep a constant tension in the string. Okay, so here at this point I've got the force of gravity and I've got the force of tension, and let's just say that they're balanced at that point. Well, they can't be balanced, or it wouldn't be going in a circle, so my tension, let's just say, is just large enough to get it going through. So at that point I'm going to balance out, and my overall acceleration is going to be a very small acceleration, right? Because that's the force, the centripetal force, balancing that tension and that gravity. When I get over to the side, okay, if I still assume that my tension is equal to what it was before, and the force of gravity is equal to what it was before, then my overall force is going to be the sum of those two, which is going to be something in this direction. And so now my acceleration is going to be in that direction, which is not going to give me a vertical circle. Okay, so we have to keep in mind that this acceleration, yes, must be, the acceleration has to be constant. That is not possible if I keep a constant tension here, especially if they're always going to the center of the circle. All right, so basically the point of that is I wanted us to talk through, look at the forces, look at the accelerations, understand that vertical circles are going to be a little bit more complex than horizontal circles are. Remember to include both the tension and the acceleration due to gravity. Okay, most of the time your object's going to be going fast enough that it's going to require both the force of gravity and the tension here to keep it going in this circle, right? You can feel that when you're swinging your rock around really fast. It feels like the string's going to fly out of your hands. Well, that's because you are pulling on the string, and therefore the string is pulling back on you. Newton's third law once again. And so you feel that as it's going around. And so it's very, very common for this to be the case, all right, where you have both gravity and your tension. And so let's just look really quick at that last situation. Let's assume right now that the force of gravity and tension are both giving you this acceleration, which is going to be that large now towards the middle. Okay? At the bottom then, so if I'm at the bottom, force of gravity is still the same. What has to happen in order for me to be able to maintain this same acceleration, the same that acceleration that is that large? Well, once again, remember, this has to balance out gravity and then still has to give that acceleration. So it's got to give that centripetal force plus balance out the force of gravity. And so this orange right here is going to represent the force of tension required. Okay, so just remember that. Kind of think about that as you think about things in vertical circles, that forces are going to be different in different locations in order to maintain that circular motion. All right? And that's all I'm going to talk about in this video. I know it's long. If you need to go back over individual pieces, go for it. You're probably ready that you can start looking at some problems, okay? Just pay attention to the fact that we're looking at centripetal acceleration, which is caused by forces. Has to be caused by some kind of force pointing towards the middle. That's all. Good luck.